So let us first understand the meaning of plug and play tool design, the definition of it. So plug and play tool design means tools that can be added, removed, or replaced without changing core agent logic. So plug and play tool design means in such design, tools can be very easily added, removed, or even replaced without changing the core agent logic. So tools addable, removable, or replaceable without changing the core agent logic. So plug and play tool design is a design principle which lets us to add a new tool, remove a existing tool, or replace a existing tool without even touching the core agent logic. So the agent should not need to know the inner workings of a tool to use it effectively. So in plug and play tool design, agent does not need inner working knowledge of the tools. Agent only needs to know how to snap it into place. Only how to snap it in place, like building blocks. So plug and play tool design, this design principle is like tools should be very easily pluggable to the agent, wherein agents are completely unaware about the tool's internal workings. Agent should just know that, okay, what that tool can do, how to call it, and what response an agent can expect. Only that information agent needs to know. And in plug and play tool design principle, tools should be very easily be able to add, remove, or replace without changing the core agent logic. So this is the plug and play tool design in agentic AI systems. Now let us look at the characteristics of plug and play tool design. Characteristics of plug and play tool design. So in a plug and play tool design, we have standardized interface. So we have a standardized interface. So every tool follows the same structural wrapper. So every tool, it has to follow the same structural wrapper. So we call it the standardized interface. And with this, it will be very easy to plug any new tool we want, replace an existing tool, or remove an existing tool. So in plug and play tool design, the AI agent will have a standardized interface and every tool follows the same structural wrapper. So this is one very important characteristics of plug and play tool design. Now other characteristics, if we look at, so plug and play tool design, we have self-descriptive metadata. So every tool will have a self-descriptive metadata. So tool will have some metadata which will describe like what that tool is about, what it can do, what inputs it will take, what will be the format of the output. So self-descriptive metadata, and agent uses this self-descriptive metadata of a tool to decide when and why to call a particular tool. So in plug and play tool design, every tool will have a self-descriptive metadata like information like the name of the tool, the description, like what that tool is about, the inputs it can take, the outputs it can generate. And now the third very important characteristics of plug and play tool design, it is the independent execution. Now this is very important. Now every tool can execute independently. Like when the tool is executing, it has nothing to do with the AI agent. So that is the independent execution. So a plug and play tool contains everything it needs to run. So a plug and play tool, it contains everything needed to run, like its own libraries, runtime environment, logic. It does not rely on the agent's memory or other tools to function, making it highly portable. So plug and play tool, if I talk about it, is highly portable, wherein every tool has got its own runtime environment. it has got everything it needs to run: the libraries, the logic, the authentication, authorization, and a tool is completely independent of agent, like agent's memory or any other tool. So this is a very important characteristic of a plug and play tool, that is the independent execution. So here we have a tool. So everything the tool needs is there with it. A tool will run it, run on its own independently without depending on the agent's memory or any other tool. So we looked into the characteristics of plug and play tool design, wherein we saw that agentic AI, the AI agent, it should have a standardized interface wherein every tool, every plug and play tool will follow the same structural wrapper. Every plug and play tool will have a self-descriptive metadata, like the name of the tool, the description, what it can do, the inputs it can take, the outputs it can generate. And this self-descriptive metadata will help agent in deciding when and why to call a particular tool. And plug and play tool, they execute independently, like they contain everything they need to run, and they run independently without depending on the agent or any other tool. So these are like some very important characteristics of plug and play tool design. Now let us look at an example to get more clear understanding. So now we will look at a tool interface example. So now we are looking at a self-descriptive metadata of a plug and play tool. So as we can see, we have a parameter called name, which is the name of the tool. And here we are talking about a weather API tool. The description, it tells us that what that tool can do. So this tool can fetch current weather. Then we have inputs, like the inputs which this tool can take, the parameters. So this tool can take one input parameter, that is the city, and the data type is the string, and the outputs, like what response can we expect from this tool. So this tool will output temperature, which is the float data type. So we looked at an example of a tool interface, like example of a plug and play tool, the self-descriptive metadata we saw. So every tool will have a self-descriptive metadata where we will be having the name of the tool, the description, like the what the tool does, the inputs, the outputs. Now let us look at plug and play tool design principles. So now we will discuss the design principles. So basically design principles are the rules you follow to ensure the agent does not get confused or break the system. So design principles are like very important rules to prevent confusion and system breakage. So design principles are the rules which prevents the confusion and system breakage. So for plug and play tool design, the design principle, if we talk about, input output schema consistency is very important. So as we already saw that every plug and play tool follows a standardized interface wherein input output schema, it follows a standard input output schema. And because of that, because of the standard input output schema, there will never be any confusion or system breakage. If we talk about plug and play tool design principle, so plug and play tools, we have stateless execution. So this is very important, stateless execution. So the plug and play tool, they should not remember previous calls. Every time it runs, it starts from scratch. So that is what is stateless execution is. And this is very important because with the stateless execution, we can keep the system very simple. And stateless execution will keep the things very simple, no complications. So stateless execution means the tool should not remember the previous calls. Every time the tool runs, it starts from scratch. So no memory of previous calls. And by being stateless, the tool is more resilient and easier to test in isolation. So now it's very clear to us that the plug and play tools, it has to be stateless. And one more very important design principle is the clear documentation. Clear documentation. So in agent systems, documentation is for the large language model. And why documentation is important? It is not for humans, but it is for large language models. Because we know that in agentic AI systems, large language models will be the orchestrator. They will be calling the tools. And in order to call a tool, large language models should be aware of the tool. And they will be aware of the tool if they are provided with a clear documentation. If they know that, okay, it has a tool which can perform this set of actions, then definitely LLM will be aware that, okay, it has got certain tools with certain capabilities, and wherever there is a need, it can call a particular tool. So clear documentation. So now we looked into some very important design principles for plug and play tools. So plug and play tools should follow a standard input output schema, so that very easily we can plug it to any AI agent. Plug and play tools, they should follow stateless execution. So it should not keep a memory of previous calls. Every tool call should start from scratch, and it makes the tool more resilient and easier to test in isolation. And every plug and play tool has to have a clear documentation. And this documentation is for the LLMs and not humans. Now let us look at the benefits of plug and play tools. Let us look at the benefits of plug and play tools. So see, plug and play tools, it allows rapid experimentation, because we know that plug and play tool, it is very much independent from the agent's core logic. Very easily we can plug it, we can test it, we can run it in isolation, and we can perform rapid experimentation to test a particular feature, to test a particular functionality. So plug and play tools, it allows rapid experimentation, easy upgrades. Very easily we can upgrade a plug and play tool, because any changes you make in the plug and play tool, it has nothing to do with the agent system. Agent system is very much independent of the plug and play tool. And this isolation, this modularity makes things very easy. So plug and play tools, if we talk about the benefits, easy upgrades and reusability across agents. Reusability across agents. So this is something very interesting. Like, let us suppose you designed some very interesting plug and play tools. Now you can use those plug and play tools across many different agents. So design, like once you put effort to design a tool, and you can reuse it wherever you want. So reusability across agents. So now we saw some very interesting benefits of plug and play tools, wherein we looked at plug and play tools. It allows rapid experimentation, easy upgrades, and reusability across agents. So with plug and play tool design, what result we can achieve? Let us look at that. The result we can achieve if we use plug and play tool design. So with plug and play design, your agent becomes a dynamic orchestrator. And what it means, let us see. So with plug and play design, your agent becomes a dynamic orchestrator. It means that you can give your agent a toolbox of 50 tools. For example, like you can give your agent a toolbox containing lots of standardized tools. For example, like 50 plus standardized tools. So now we have an AI agent which can access 50 plus standardized tools, and these tools are basically plug and play tools. These tools follow all the design principles of plug and play tools, like standard input output schema, stateless execution, clear documentation, and agent i- can access these standardized tools. And because they are standardized and they contain self-descriptive metadata, the agent will naturally pick. So with plug and play design, your agent can naturally pick the right tool every time for the job. So whatever the job needs to be done for a particular job, it will pick the right tool, because all these tools, the plug and play tools, they are standardized tools. They contain clear documentation. So the agent, the LLM is aware about the capabilities of all the tools. So with plug and play tool design, your AI agent becomes a dynamic orchestrator.